Hello. Remember how we were going to build a website to control our LEDs? Oh my gosh, it works! Let's talk about it! Welcome back to EEforEveryone. I made a couple promises in the previous episode. I promised that today I would have ported my frame generation and LED strip TCP client code into an object-oriented programming type mindset for easier multi-threading. I also promised that my Frexpert software engineer would build a web interface for submitting animation sequences to the LED driver, and then these two pieces of software would get merged into one beautiful work-in-progress piece of ugly, but functional, code. Well, I'm happy to report that after a 6-hour call/code jam session, it's done. And it's so cool! I want to preface this with, this is how projects come together. There's a well-defined challenge that can be communicated from one person to another person. If your task is well-defined enough, it doesn't matter who executes it or how. If each person solves the challenge to the specifications, the pieces will bolt together seamlessly. And they did perfectly. We both took a stab at writing some code to implement the core functionality required for the system. All the radio buttons don't work yet, only one type of animation can actually be used, and the transition time and dwell time fields don't really do anything yet. However, the data flows from the user request in the Tomcat server to the LED strip frame generator/TCP session manager, and it ends up showing up on the LED strips. This is so exciting. Click a button in a browser window, and then your LED strips come to life. Once the core functionality is implemented, we can work on building automatic reconnection, multi-threading, performance improvements, etc. This is the first step, where we're making sure that we're headed down the right path before we design all of the code to 100%. With this in mind, the software isn't really pretty yet, but there's plenty of time to put lipstick on this pig. Before I get ahead of myself, let me try to explain what's going on in the software and what changed from last week. The frame generator, now in a Java class, has methods to generate frames of a particular size. You pass in the animation algorithm you'd like, the number of pixels in the strip, and the number of frames you'd like the animation to be stretched over. Once set up, calling the run method will return the next frame as a byte array, until the animation is complete, when the next animation can be set up and ran. The frame generator does this in such a way that each animation generator can be incremented in lockstep with one another. We can increment all the animations, transmit that frame to all the strips, rinse and repeat. So even if the strips have different lengths and these processes take more or less time for each individual strip, they'll all start at the same time and they'll end close enough to the same time that you probably won't be able to tell the difference. Based on which setup function is called, the actual frames coming out of the frame generators in the run method will change. But the general process isn't really any different. You set up your animation, you call run, and every time you call run, you get the next frame to transmit to the LEDs. This used to be implemented in a for loop that needed to be executed free running in a single thread from start to finish, or it would have broken. That wouldn't have allowed for synchronizing the multiple animations, and in fact, you'd have to play the whole animation on one strip before you started playing the animation on the next strip. That's not going to work, so that had to be recoded. Now the LED strip class. This is past a TCP socket for an active connection to an LED strip and the number of pixels received in that first ping message. Then it creates an input and output stream. There is a double frame buffer here. One incoming buffer where the next frame is loaded into, and then the free running transmission thread will check for when the incoming and outgoing buffers don't match, and when they don't, it'll pull the incoming buffer into the outgoing buffer and then transmit through the TCP socket. The class needs to be updated to clear out any idle TCP packets sent by the Arduino LED strip client to prevent interpreting these idle packets as acknowledgements when transmitting, but that's small potatoes. The last part of this system is the voodoo software nonsense magic that my friend put together to handle the Webserver stuff. If you'd like him to give a little more detail on how all that Java stuff works, give him some encouragement by leaving your questions in the comments. The general idea is that there'll be one master thread that gets spun up by the Tomcat server. This master thread will spin up an LED strip TCP client acquisition thread, and then spin up a TCP transmission thread for every client that's acquired. This can happen at any time. When the Tomcat server is passed an animation set from a web browser client, it'll pass this information to the master thread. The master thread will then index through the requested steps in the animation sequence, generating the frames and pushing these frames into the incoming buffer of the connected LED clients in lockstep with one another. At this point, the slave threads, which are managing the individual TCP streams, will transmit the new frame to each of their clients, and then the next frame will be generated and transmitted once each of those slave threads sets their transmission complete flag. The way that our software is written is that the user can add any number of animation steps to the sequence in the browser window, and then this data set is pushed over to the Tomcat server, which parses it. I'd love to distribute the code right now so you can experience the awesome power of LED strips backed by the horsepower and networking of a full computer. Again, I don't want you to just get buried in the bugs that we've created, so give us the proper time to finish this well, and you'll have the source code soon enough. I promise. Things left to do in the next couple weeks are to implement multi-threading for the TCP transmission, multiple client acquisition, changing animations on the fly in the browser, a software off switch to make the LEDs go black so it doesn't keep sucking power when I want to go to bed, and performance improvements / compression if that turns out to be necessary, even with the additional horsepower of a full computer. This animation software is currently using 60% of my VM's CPU for the Tomcat server plus one transmission thread. Good thing it's a VM! This will let me allocate more cores as necessary to give it the horsepower it needs to drive these LED strips. If I need to build a new server to handle enough LED strips, so be it. Oh yeah. Oh yeah. Oh yeah. I like it.
After we had like a hour-long conversation, I was like, this is gonna take a while. Even after I knew what you were gonna do, you know, I knew what you had committed to do, and still even thinking about that. And granted, I guess we haven't done all the threading stuff, but like still. We've proven that we can work successfully together, so at this point, we can get pretty much anything we want to do.
That flew together.
Beautiful, because like we each had a totally clear area of what we had to do, you know?
Mm-hmm.
Like, and we just did it.
Mm-hmm.
Flawlessly.
It took a surprisingly similar amount of time too.
Yeah, really.
Like within 20 minutes, we were done. This is absolutely incredible. Like, I just want you to think about what's happening right now. Like,
oh, I know.
Like, the whole, like, incredibleness that is happening. I don't really have a schedule for finishing up this project. It's one of those things that's just going to take as long as it takes. I'm new to Java, I'm new to Tomcat servers, I'm new to every part of this project except for the 10 lines of code running on the Arduino client. With that in mind, I need to lean pretty heavily on the experience of my friend who's more familiar with the pieces of the software system, because he can debug my simple mistakes or just write the high-level code much faster than I can. We're both very passionate about this project and very excited to see it start to come together. We'll get this finished up as fast as humanly possible so we can share it with you. If you think that this Wi-Fi LED server project is cool and this video is great, let me know by hitting the like button on this video, subscribing to the channel, or leaving a comment letting us know what you enjoyed. Most of all, I hope that you learned something great today, and I hope to see you again soon. Bye!